October 1962. North Atlantic Ocean, Soviet submarine K-19 cruised at periscope depth 300 miles east of Newfoundland, her diesel engines driving her toward patrol station near Cuba. Captain Nikolai Zateyev stood in the cramped control room monitoring depth gauges and speed indicators. The submarine had departed Murmansk 2 weeks earlier, with orders to support Soviet operations during what would become the Cuban Missile Crisis. Zateyev believed his submarine was undetected, invisible beneath Atlantic waves, just as Soviet doctrine promised. 2,000 miles away at Naval Facility Argentia, Newfoundland, U.S. Navy sonar technician, 3rd Class Robert Morrison, adjusted his headphones and studied the waterfall display, showing acoustic signatures detected by SOSUS hydrophone arrays on the ocean floor. The distinctive sound pattern of Soviet diesel-electric propulsion was unmistakable. Morrison marked the contact, calculated bearing and range, and forwarded the tracking data to Atlantic Fleet headquarters. K-19's entire transit across the Atlantic had been monitored from the moment she cleared Soviet territorial waters. American destroyers and P-3 Orion patrol aircraft were already being vectored to intercept. Soviet submarine stealth was an illusion that SOSUS had shattered. U.S. Navy Admiral George Anderson later briefed President Kennedy on Soviet submarine movements with confidence that shocked civilian officials unfamiliar with American underwater surveillance capabilities. "We know where every Soviet submarine is," Anderson stated. The declaration wasn't bravado. It was accurate assessment based on intelligence that SOSUS provided continuously. Soviet submarines that departed their bases believing the ocean's vastness would protect them were tracked from departure to destination by hydrophone arrays that detected propeller noise at ranges Soviet captains couldn't imagine. For the Soviet Union, submarine forces represented their most potent naval weapon and their best hope for challenging American surface ship dominance. The Soviet submarine fleet in the 1960s numbered over 400 boats, the largest underwater force in the world. The majority were diesel-electric submarines, Project 613, Whiskey-class boats with 350-ton displacement, Project 633 Romeo-class submarines designed for coastal patrol, and Project 641 Foxtrot-class boats capable of extended ocean patrols. Nuclear-powered submarines were entering service with November-class attack submarines, commissioned starting in 1958, and Hotel-class ballistic missile submarines that would carry nuclear weapons within striking range of American cities. Soviet naval doctrine emphasized underwater warfare as the domain where numerical superiority could offset American advantages in aircraft carriers and surface combatants. Soviet submarines outnumbered American submarines by ratios approaching 3-to-1 in some years. Soviet planners calculated that in wartime, their submarine fleet could attack American carrier groups, interdict Atlantic supply lines, and threaten coastal cities with ballistic missile launches. The strategy depended on one critical assumption, that submerged submarines were effectively undetectable by surface forces. This assumption rested on World War II experience, where German U-boats had operated with near immunity from detection until convoy escorts closed to ranges measured in hundreds of yards rather than miles. Sonar technology during World War II was primitive. Active sonar could detect submarines at ranges under 2,000 yards. Passive sonar was even shorter ranged, and both systems were defeated by ocean temperature layers and ambient noise. Soviet submariners who had served during World War II knew that once a submarine submerged and maintained silent running procedures, surface forces searching millions of square miles of ocean had minimal chance of locating them. Soviet confidence in submarine stealth shaped operational planning throughout the 1950s and early 1960s. Submarines could operate freely in the Atlantic, approaching American coastlines without detection. American anti-submarine forces couldn't find individual submarines in ocean expanses that stretched thousands of miles in every direction. The vastness of the ocean protected Soviet submarines the way distance and terrain had protected guerrilla forces throughout military history. Soviet admirals planned submarine deployments assuming that once boats cleared their bases and submerged in deep water, they became effectively invisible until they chose to attack or surface. The Cuban Missile Crisis in October 1962 represented the first major test of Soviet submarine doctrine against American anti-submarine capabilities that Soviet planners didn't fully understand. 4 Foxtrot-class submarines were ordered to escort Soviet merchant ships carrying missiles to Cuba and to deter American naval forces from enforcing a blockade. The submarines would demonstrate Soviet resolve, complicate American military planning, and show that Soviet naval power could operate in the Western Hemisphere. Soviet commanders expected the submarines to transit undetected and arrive in Cuban waters before American forces realized they were present. What Soviet planners didn't know was that American underwater surveillance had evolved far beyond World War II sonar technology. The sound surveillance system, SOSUS, represented a revolution in ocean monitoring that rendered Soviet submarine stealth doctrine obsolete before Soviet naval intelligence understood such a system existed. SOSUS had been conceived in 1949 by Dr. Gordon Hamilton and scientists at Columbia University who understood that sound propagates through water far more effectively than through air. Low-frequency sound waves could travel hundreds or even thousands of miles through the ocean's deep sound channel, a layer of water where temperature and pressure created conditions that trapped sound waves and prevented them from dissipating toward the surface or bottom. Submarines operating anywhere in the world's oceans generated acoustic signatures. Diesel engines produced distinctive mechanical noise. Propellers created cavitation sounds as blades churned through water. Hull vibrations transmitted through the ocean as submarines maneuvered. Hamilton proposed a system of hydrophones, underwater microphones, deployed on the ocean floor and connected by cables to shore stations, where operators could listen continuously for submarine acoustic signatures. The concept seemed almost impossible to implement. Hydrophones would need to be sensitive enough to detect quiet submarines at extreme ranges. Cables would need to transmit signals reliably across hundreds of miles of ocean floor. Shore stations would need trained personnel capable of distinguishing submarine signatures from ambient ocean noise. Whale songs, merchant ship propellers, seismic activity, and countless other sounds that filled the underwater environment. The US Navy committed to SOSUS development in the early 1950s, understanding that strategic warning of Soviet submarine movements would be worth enormous investment. The first arrays were deployed in the Atlantic along the Guyuk Gap, the ocean passage between Greenland, Iceland, and the United Kingdom that Soviet submarines would need to cross to reach American coastlines or Atlantic shipping lanes. Additional arrays were positioned in the Pacific near Soviet submarine bases at Kamchatka and Vladivostok, creating barriers through which Soviet submarines couldn't pass undetected. The technology that made SOSUS effective represented cutting-edge hydrophone design, signal processing, and acoustic analysis. Each hydrophone array consisted of multiple sensors spaced across miles of ocean floor, providing the triangulation data necessary to determine not just that a submarine was present, but exactly where it was located. The hydrophones detected low-frequency sound in ranges between 10 and 500 Hz, frequencies that diesel engines and propeller systems produced naturally and that propagated efficiently through the deep sound channel. Shore stations designated naval facilities, NAVFAC in Navy terminology, housed the operators who monitored hydrophone feeds continuously. NAVFAC personnel underwent extensive training in acoustic signature recognition, learning to distinguish Soviet submarine types by the specific sounds their propulsion systems generated. A Project 6113. Whiskey-class diesel submarine sounded different from a Project 641 Foxtrot. A November-class nuclear submarine's reactor coolant pumps produced acoustic patterns distinct from diesel engines. Experienced operators could identify not just submarine class, but sometimes individual boats based on unique acoustic characteristics caused by manufacturing variations or mechanical wear. The system's coverage was designed around 2 concepts: barrier arrays that monitored transit routes Soviet submarines would need to cross, and queuing arrays positioned near Soviet bases that detected submarines as they departed on patrol. Once a submarine was detected, its acoustic signature was recorded and tracking data forwarded to anti-submarine warfare coordination centers, where P-3 Orion patrol aircraft, surface ships, and American attack submarines could be directed to maintain contact. The ocean that Soviet planners believed was too vast to monitor had been transformed into a surveillance zone where submarine movements were detected, tracked, and reported with reliability that Soviet naval intelligence didn't suspect until the 1970s. The cost of SOSUS was enormous, but considered justified by the intelligence value. Exact expenditures remain classified, but estimates suggest hundreds of millions of dollars were invested during the 1950s through 1980s. Thousands of miles of armored undersea cables connected hydrophone arrays to shore stations. Dozens of NAVFAC installations were constructed and staffed with personnel trained in acoustic analysis. The infrastructure required to maintain continuous surveillance of Soviet submarine movements dwarfed anything Soviet engineers could replicate, even if they understood what the Americans had built. Detection ranges depended on submarine type and operating conditions. Diesel-electric submarines were loud. Their engines, generators, and propellers created acoustic signatures detectable at ranges between 500 and 1,000 miles under favorable conditions. Nuclear submarines were quieter because they didn't need diesel engines for propulsion, but reactor coolant pumps and steam turbines still generated noise that SOSUS detected at ranges of 100 to 500 miles. The system's sensitivity meant that Soviet submarines needed to be extraordinarily quiet to avoid detection. Quieter than Soviet manufacturing technology of the 1950s and 1960s could achieve. Security around SOSUS was extraordinary. The system was classified top secret, with additional compartmented access restrictions. Soviet intelligence had no indication that such comprehensive ocean surveillance existed. Soviet submarine captains operated throughout the 1950s and early 1960s, believing their operations were undetected, never suspecting that American hydrophones were tracking their movements from the moment they left port until they returned. The Cuban Missile Crisis shattered Soviet assumptions about submarine stealth with brutal efficiency. 4 Foxtrot-class submarines, B-4, B-36, B-59, and B-130, departed Soviet bases in early October 1962, with orders to transit to Cuban waters and support Soviet operations there. Each submarine carried 22 torpedoes and 1 nuclear-tipped torpedo intended for use against American aircraft carriers if war erupted. The submarines were ordered to remain undetected during transit, maintain communications silence, and arrive in Cuban waters to deter American naval action. SOSUS detected all 4 submarines within hours of their departure. As each Foxtrot crossed SOSUS barrier arrays in the Atlantic, shore stations triangulated positions and forwarded tracking data to Atlantic Fleet headquarters. American naval forces deployed hunter-killer groups, destroyers equipped with sonar systems and anti-submarine weapons, to maintain contact with the Soviet submarines and apply pressure that would prevent them from approaching Cuba undetected. The tactics employed against the Soviet submarines were designed to force them to surface without sinking them. Escalation that might trigger war. American destroyers dropped practice depth charges, explosive devices that created shockwaves and noise but didn't contain warheads capable of sinking submarines. The message was clear. We know where you are. We can attack you at will. Surface immediately. For Soviet submarine commanders who believed they were operating undetected, the sudden appearance of American destroyers precisely positioned to attack was devastating psychological shock. Soviet submarine B-59, commanded by Captain Valentin Savitsky, was subjected to particularly intense pressure. American destroyers had been tracking the submarine for days, dropping practice grenades continuously to force surfacing. Inside the submarine, conditions were desperate. Air conditioning had failed in tropical waters. Carbon dioxide levels were rising. Batteries were depleted from running submerged to evade American forces. The crew was exhausted, dehydrated, and approaching the limits of human endurance. Captain Savitsky, believing his submarine was under actual attack rather than harassment, decided to prepare the nuclear-tipped torpedo for launch. Soviet protocol required approval from the captain, the political officer, and the flotilla commander to authorize nuclear weapon use. B-59 happened to have all 3 officers aboard. 2 of the 3, Savitsky and political officer Ivan Maslenikov, approved arming the nuclear torpedo. The third officer, Flotilla Commander Vasily Arkhipov, refused permission. Without unanimous consent, the weapon couldn't be launched. Arkhipov's decision prevented nuclear escalation that might have triggered World War III. B-59 surfaced on October 27, 1962, surrendering to American harassment. The other 3 Foxtrot submarines similarly surfaced under American pressure. All 4 submarines returned to Soviet bases, having failed to reach Cuban waters undetected. The Cuban Missile Crisis submarine operations demonstrated conclusively that SOSUS had rendered Soviet submarine stealth obsolete. Soviet submarines couldn't cross the Atlantic undetected. They couldn't evade American anti-submarine forces once located. And the psychological pressure of operating under constant surveillance degraded crew performance to dangerous levels. Throughout the 1960s and 1970s, SOSUS provided continuous tracking of Soviet submarine movements. Soviet submarines departing Murmansk, Severomorsk, or Vladivostok were detected by cueing arrays within hours. As submarines transited through barrier arrays crossing the Gyuk Gap or Pacific choke points, their positions were updated and anti-submarine aircraft were launched to maintain contact. P-3 Orion patrol aircraft would deploy sonobuoys, disposable hydrophones that provided localized acoustic data, to confirm submarine positions and maintain tracking during the critical period when submarines approached their patrol areas. Soviet submarines never reached patrol stations undetected. Captains who believed they were invisible beneath the waves were actually tracked continuously from departure to arrival. American attack submarines could be positioned to shadow Soviet ballistic missile submarines, maintaining constant awareness of their locations in case war required immediate neutralization. The strategic deterrent that Soviet submarine-launched ballistic missiles were supposed to provide was compromised because American forces knew where the submarines carrying those missiles were located. A specific incident in 1968 demonstrated SOSUS's capability beyond routine submarine tracking. Soviet submarine K-129, a Gulf-class diesel-electric boat carrying 3 nuclear-tipped ballistic missiles, sank in the Pacific Ocean northwest of Hawaii. The exact cause of sinking remains unclear: possible battery explosion, hull failure, or collision. Soviet Pacific Fleet lost contact with K-129 and began searching an area encompassing millions of square miles. SOSUS hydrophone arrays in the Pacific had detected an acoustic event consistent with a submarine hull implosion. The detection data allowed American analysts to narrow the search area to a region approximately 400 miles in diameter, still vast, but dramatically smaller than the search zone Soviet forces were investigating. The CIA launched Project Azorian, a covert operation using a specialized recovery vessel disguised as a commercial deep-sea mining ship. The operation successfully recovered portions of K-129 from a depth of 16,500 feet, providing American intelligence with Soviet ballistic missile technology, nuclear warhead designs, and code materials. SOSUS had made the recovery possible by narrowing the search area to dimensions where deep-sea search technology could be effective. Soviet military intelligence began suspecting that American anti-submarine capabilities exceeded what Soviet doctrine anticipated during the late 1960s. The pattern of American submarine tracking was too consistent to be explained by chance encounters. Soviet submarines were being located too quickly after departing their bases. American anti-submarine aircraft appeared too rapidly in positions that suggested advanced knowledge of Soviet submarine locations. By the early 1970s, Soviet naval intelligence had concluded that some form of fixed underwater surveillance system must exist, though they didn't understand its full extent. Confirmation came through espionage. John Walker, a US Navy communications specialist, began providing classified information to Soviet intelligence in 1968. By the mid-1970s, Walker had delivered information about SOSUS capabilities, coverage areas, and operational procedures. Soviet naval leadership finally understood what they faced: a comprehensive ocean surveillance system that had been tracking their submarines for 2 decades. The revelation transformed Soviet submarine development priorities: quieter propulsion systems, anechoic coatings to absorb sonar transmissions, and operational procedures designed to minimize acoustic signatures became urgent requirements. Soviet submarine designers attempted to close the acoustic gap during the 1970s and 1980s. Improved propeller designs reduced cavitation. Better machining precision for shaft bearings decreased vibration. Anechoic rubber coatings on submarine hulls absorbed some sound energy. Victor III class nuclear submarines, introduced in 1978, were significantly quieter than earlier Soviet designs. Akula-class submarines entering service in 1986 achieved acoustic quieting that Western analysts considered approaching American submarine standards, but the improvements came decades late. Throughout the 1950s, 1960s, and most of the 1970s, Soviet submarines operated at acoustic disadvantage that SOSUS exploited completely. By the time Soviet submarines achieved acoustic quieting comparable to American standards, SOSUS itself had been upgraded with SURTAS, Surface Towed Array Sensor System, where surface ships towed hydrophone arrays that could be repositioned dynamically rather than being fixed to the ocean floor. The technology race continued with American acoustic detection, maintaining advantages over Soviet submarine quieting throughout the Cold War. The fundamental technology gap that enabled SOSUS dominance was threefold. American hydrophones were more sensitive than Soviet submarine designs were quiet. American signal processing could extract submarine signatures from ambient ocean noise more effectively than Soviet submarines could mask their acoustic output, and American manufacturing precision produced submarine components that generated less noise than equivalent Soviet machinery. Soviet diesel submarines from the 1950s and 1960s were loud because their engines, generators, and propellers were built with manufacturing tolerances that allowed excessive vibration and noise. Soviet nuclear submarines were quieter than diesel boats but still noisier than American nuclear submarines because metallurgy, machining, and quality control in Soviet shipyards couldn't match American standards. Soviet doctrine failure compounded the technology gap. Soviet naval planners had assumed that the ocean was too vast to monitor comprehensively. Atlantic and Pacific expanses covering tens of millions of square miles seemed impossible to surveil with technology available in the 1950s. The assumption was reasonable based on World War II experience where vast ocean areas were effectively unmonitored. What Soviet planners had unanticipated was that Americans didn't need to monitor every square mile of ocean. They needed only to monitor strategic choke points and transit routes that Soviet submarines would be forced to use by geography. Soviet submarines based at Murmansk and Severomorsk needed to transit through the Gyuki Gap to reach Atlantic patrol areas. Submarines based at Vladivostok and Kamchatka needed to pass through relatively narrow straits to reach Pacific patrol areas. These choke points could be monitored with fixed hydrophone arrays that covered limited ocean areas, but captured all submarine traffic passing through strategic waterways. The Soviet Union's geographic position, surrounded by NATO nations and allied countries, meant their submarines couldn't reach operational areas without transiting through waters that Americans could monitor. Soviet attempts to develop equivalent underwater surveillance capability during the 1970s and 1980s faced insurmountable obstacles. Building hydrophone arrays required undersea cables, shore stations, trained personnel, and signal processing infrastructure. Soviet shipyards were building submarines as fast as possible to maintain numerical advantage over American submarine forces. Resources diverted to underwater surveillance would reduce submarine construction. Soviet leadership chose to prioritize offensive capability over defensive surveillance, a decision that perpetuated American advantages in ocean monitoring. By the 1990s, as the Cold War ended, US Navy possessed such comprehensive knowledge of Soviet submarine movements that American anti-submarine warfare commanders could account for the location of virtually every Soviet submarine. Ballistic missile submarines that were supposed to provide secure second strike capability were tracked continuously. Attack submarines intended to threaten American carriers were shadowed by American submarines that maintained contact throughout their patrols. Soviet submarine forces that had been designed to offset American surface ship advantages were neutralized by surveillance technology that Soviet naval architects had not anticipated when designing boats in the 1950s and 1960s. SOSUS served American anti-submarine warfare from the 1950s through the 2000s, providing continuous ocean surveillance that shaped naval operations for 5 decades. Portions of the system were declassified in 1991 after the Cold War ended and Soviet submarine threat diminished. Hydrophone arrays that had listened for Soviet submarines were converted to scientific applications. NOAA, the National Oceanic and Atmospheric Administration, began using SOSUS arrays for oceanographic research, tracking whale migrations, detecting underwater volcanic activity, and monitoring seismic events. The same hydrophones that detected Soviet diesel engines could track the distinctive calls of blue whales across entire ocean basins. Successor systems continue providing underwater surveillance capability, though specific details remain classified. SOSUS represents the evolution from fixed arrays to mobile systems that can be repositioned based on operational requirements. Modern underwater surveillance networks integrate fixed hydrophones, towed arrays, autonomous underwater vehicles, and satellite communications to maintain awareness of submarine activities worldwide. The fundamental concept that SOSUS pioneered, comprehensive ocean surveillance through acoustic detection, remains central to American anti-submarine warfare capability. The Soviet submarine threat that had dominated American naval planning from the 1950s through the 1980s was largely neutralized by SOSUS. Soviet ballistic missile submarines that were supposed to provide strategic deterrent capability were tracked continuously, making them vulnerable to American attack submarines in wartime. Soviet attack submarines intended to threaten American carrier groups operated under surveillance that allowed American forces to position defensive assets precisely where needed. The numerical advantage Soviet submarine forces enjoyed throughout the Cold War was offset by American knowledge of where every submarine was located. Post-Cold War Russia has developed quieter submarines, incorporating Western technology and improved manufacturing standards. Yasen-class attack submarines and Borei-class ballistic missile submarines entering service in the 2010s and 2020s represent significant acoustic improvements over Soviet-era boats, but American underwater surveillance has evolved in parallel, maintaining detection capabilities that continue giving American anti-submarine forces advantages in finding and tracking submarines. The intelligence impact of SOSUS extended far beyond tactical submarine tracking. The system provided strategic warning of Soviet submarine deployments, allowing American military planners to assess Soviet naval capabilities accurately rather than relying on worst-case estimates. SOSUS data contributed to arms control verification, confirming that Soviet submarine-launched ballistic missile tests occurred as declared rather than being conducted covertly. The system demonstrated that comprehensive ocean surveillance was achievable with sufficient investment in infrastructure and technology. Soviet submarines had operated throughout the Cold War, believing that the ocean's vastness protected them from detection. Soviet doctrine assumed that once submarines submerged and maintained radio silence, they became effectively invisible. Soviet captains understood they could be detected if they surfaced, if they transmitted radio messages, or if they encountered enemy forces at close range. But the concept that American forces could detect them at ranges exceeding 1,000 miles, could track them continuously across entire ocean basins, and could maintain surveillance from the moment they left port until they returned, seemed impossible based on World War II experience and Soviet understanding of sonar technology. SOSUS turned those impossibilities into operational reality. 1,000 miles of ocean became a detection zone rather than a hiding place. Hydrophone arrays on the ocean floor listened continuously, processing acoustic signatures with sensitivity that Soviet submarine designers couldn't defeat. Shore stations staffed with trained operators analyzed submarine sounds, calculated positions, and dispatched hunter-killer forces that maintained pressure on Soviet submarines throughout their patrols. The technology gap wasn't measured in the number of submarines each side deployed. Soviet numerical superiority in submarine forces was real. They had more boats than American and NATO navies combined. The gap wasn't measured in maximum diving depth or speed. Soviet submarines achieved impressive performance in both areas. The gap was measured in something more fundamental: Americans were listening to every propeller revolution, tracking every submarine movement, and maintaining awareness of Soviet underwater forces, while Soviet captains believed they were operating undetected beneath protecting waves. Soviet submarines were designed to hide in the ocean's vastness. American hydrophones turned that vastness into a surveillance zone. And the difference between hiding and being hunted was measured in the acoustic signatures that Soviet diesel engines produced, and the hydrophone sensitivity that American technology achieved, creating a detection range of 1,000 miles that rendered Soviet submarine stealth as obsolete as surface warship armor became when aircraft carriers appeared.